To factor using the sum and difference of cubes, there's two formulas that you need to know. The sum of two cubes is a cubed plus b cubed. To factor that, we're going to use this formula. A plus b times a squared minus ab plus b squared. To factor the difference of two cubes, where we subtract between our two cubes, we use this formula. A minus b times a squared plus ab plus b squared. In order to factor using the sum and difference of two cubes, we need to take our cubic binomial and rewrite it as something cubed minus something cubed. Well, 8x cubed can be rewritten as 2x quantity cubed. If I distributed this 3 into the parentheses, I would have 2 cubed, which is 8, and x cubed, minus 5 cubed. So here is my a value, here is my b value. I'm going to use this second formula, and I plug in 2x for a and 5 for b. So I'm going to have 2x minus 5 times 2x squared plus 2x times 5 plus 5 squared. Now I just need to simplify. 2x minus 5. 2x squared is 4x squared plus 10x plus 25. To factor by grouping, we have a cubic 1, 2, 3, 4 quadnomial. I'm going to group my first two terms together and my last two terms together. My first two have an x squared common. So I'm going to factor an x squared out, and I'm left with x plus 2. And my last two have an 8 common. So I'm going to factor an 8 out of my last two terms. Now I've gone from 4 terms to 2 terms. Between these two terms, I have an x plus 2 common. And if I factor an x plus 2 out, I'm left with x squared plus 8. I can't factor x plus 2, and if I look at x squared plus 8, I have the sum of two squares. I can't factor this anymore because of this plus sign. The next method we're going to cover is factoring in the quadratic form. To factor in the quadratic form, we're going to factor as if our polynomial was quadratic, even though it's not. Here we have a quartic polynomial, but it's a quartic binomial. Well, I can factor a quadratic binomial. I'm going to factor this quartic binomial as if it were quadratic. So the first two terms have to multiply together to give me 81 x to the 4th. Well, in this case, it's going to be 9x squared and 9x squared. 9x squared times 9x squared gives me this 81 x to the 4th. And my last two terms have to multiply together to give me 16. So I'm going to pick a 4 and a 4. And it has to be a negative 16, so I need a positive 4 and a negative 4. If I FOILed this back out, I would end up with this polynomial. If I look, now I have a quadratic binomial and a quadratic binomial. I can't factor this quadratic binomial anymore because of this plus sign, so I'm going to leave it 9x squared plus 4. But I can factor this quadratic binomial because I have the difference, the subtraction of two squares. Two things that multiply together to give me 9x squared are 3x and 3x. And two things that multiply together to give me 4 are 2 and 2. And to make this negative, I need one positive and one negative. The reason I can factor this quadratic is because of this minus sign. When I FOIL this out, my middle term, my x term, will cancel. If I tried to factor this, I'm never going to get this middle term to disappear. It's either going to be positive 4 or negative 4. Problem 2. Before I factor anything, I have my coefficients of 4 and 20 and 24. Well, there's a 4 that's common between all of those. And if I look at my exponents, I have to the 6th to the 4th squared. So I could factor out an x squared from everything. So I'm going to factor out a 4x squared before I factor any further. If I factor a 4x squared out of 4x to the 6th, I'm left with x to the 4th. If I factor a 4x squared out of negative 20 x to the 4th, I have negative 5 x squared. And if I factor a 4x squared out of 24x, I'm left with 6. If I distributed this 4x squared back into the parentheses, I would end up with this polynomial. So I factored out this monomial. It's just 4x squared. But if I look, I have a quartic trinomial. I can factor this quartic trinomial as if it were quadratic. So I'm going to factor it into two binomials. My first two terms have to multiply together to give me x to the 4th, so I need an x squared and an x squared. My last two terms have to multiply together to give me 6. So I could pick 6 and 1 or 3 and 2. And there's two ways I can get this to be a positive 6. I could have positive 3 and positive 2, or negative 3 and negative 2. If I FOIL this right back, I should get this. X times x, x fourth, x to the 4th. X squared times negative 2 gives me negative 2x minus 3x squared. That's where my negative 5x squared comes from. Negative 3 times negative 2 gives me positive 6. If you look, 4x squared can't be factored anymore. X squared minus 3. Well, I have an x squared and I have a minus, but 3 is not a perfect square. So I can't factor this term down anymore. Here I could factor out, or I could factor 4 down because 4 is a perfect square. X squared minus 1, or x squared minus 2, I have a minus sign, but 2 is not a perfect square. So I can't factor this using the difference of two squares. So at this point, I'm done factoring. The last thing I want to go over is choosing a method. To choose a method, step 1, always factor out a monomial first. Now that's not always going to happen. If you look at example 1, there was no monomial that I could factor out. In example 2, there was. So factor out a monomial first, if possible. After that, look at the degree of your polynomial. To use the sum or difference of cubes, you have to have a cubic binomial. The highest degree of x has to be 3, and you have to have 2 terms. If we look at this very first example, we have a cubic binomial. To factor by grouping, look at the highest degree of x. We have to have a cubic quadnomial. We need 4 terms in order to factor by grouping. If we look at this example here, our highest power of x was 3, and we had 1, 2, 3, 4 terms. It was a cubic quadnomial. We could group these first 2 terms together and these last 2 terms together. And the last way to factor in the quadratic form. To factor in the quadratic form, we need to have a quartic binomial. And if we have a quartic binomial, we're going to factor the problem just like this, like it's the difference of 2 squares. Or we could have a quartic trinomial. In this example, after we factored out our monomial, we had a quartic, the highest power of x was 4, and we had 1, 2, 3 terms, so we had a quartic trinomial. And we could factor that quartic trinomial just like we factored earlier.